Subscribe now.
Welcome back to today's tutorial. In my previous tutorial, I talked about how to derive the linear combination with the matrix out of a 2-point DFT where n was 2. And today, I'm going to focus on the 4-point DFT where n equal to 4 and how we can come out with a matrix. So looking at it, the general formula as I did in the previous tutorial is x of k to be equal to summation of n equal to 0 to, let's say, 3 because 4 points, and then x of what? N. And as I said earlier on, that the omega n here represents the j2 pi over n, right? And therefore, we are going to replace it as n, nk. And as I said earlier on, k is equal to 0, 1, 2, and 3. So based on this, we can also form the linear combination equation out of it. So going forward, we can say that for x of 0, right, it means that the k is equal to 0. If k is 0, we are going to get something like the summation of what? N equal to 0, and then 3, x of what? N, exponent what? 4, 0. This means that the 4 element, all of them is going to have w4 to the power 0 plus x of 1 w4 to the power 1 plus x of 2 w4 to the power 2 plus x of 3 w4 to the power 3. And remember that as we were doing the direct computation, we were getting something like x of 0 exponent 0 plus x of 1 exponent 0 plus x of 2 exponent 0 plus x of 3 exponent 0. So this is what we are getting, and this is similar to whatever we are getting here. So based on this, we can rewrite our final. I'm not focusing on this for now, but this is the one that I've written. And we can, based on that, rewrite our final equation as x of 0 to be equal to x of 0 w4 power 0 plus x of 1 w4 power 1 plus x of 2 power 0, because they are all the same. So 2 w4 power 0 plus x of 3 and then w4 power 0. Right, so this is our equation 1. So looking for the k to be equal to 1, we are going to get x of k, or x of 1. Let me go straight away from there. X of 1 to be equal to the summation of n equal to 0, and then 3 going into x of n exponent 4n, which is equal to x of 0. The first element is 4 power 0, because when I put 0 into this straight of here, it's going to give me 0 for the first element. That's n equal to 0. So n equal to 1, it's x of 1. And then if n equal to 1, we are going to get, since k is also 1, we are going to get omega 4 1, right? Plus when n is equal to 2, since k is to 1, we are going to get x of 2 multiplied by omega 4 2 plus x of 3 multiplied by omega 4, because k is 1, and then 3. And this is going to be our equation 2, right? Or let's say, let me simplify here. So this one, we're going to write the equation as x of 1 to be equal to x of 0 omega 4 0 plus x of 1 omega 4 1 plus x of 2 omega 4 2 plus x of 3 omega 4 3. So this is our equation 2. Let's look at the second one for k equal to 2. For k equal to 2, when we pass through the same process, right? When we pass through the same process, we are going to get x of 2 to be equal to omega n equal to 0, and then 3 x of n, and then omega 4. And we say k is equal to what? 2. So if k is equal to 2, we are going to get 2n, right? We are going to get 2n, right? So based on that, when n equal to 0, we are going to get x of 1, x of 0, omega 4 0. When n equal to 1, we are going to get x1 of omega 4 2, right? And then when n equal to 2, we are going to x of 2 omega 4 4 plus when n is equal to 3, we are going to x of 3 and then omega 4 and then what 6, because 3 times 2 is what 6. So now looking at k to be equal to 3, we're going to get x of 3 to be equal to omega n. So let's say this is another equation, or let me write it here. X of 2 to be equal to x of 0 omega 4 0 plus x of 1 omega 4 2 plus x of 2 omega 4 4 plus x of 3 omega 4 6. So this is my equation 3. So my last equation, where k is equal to 3, will be n 0 and then 3 x of n omega 4 here, and then k is 3, so it's 3n, and this will give us what? This will give us x of 0. So when n is equal to 0, we are going to get omega 4 0, plus when n is equal to 1, where we are going to get 4 times 3 times 1 is what? 3, and plus when n is equal to 2, we are going to get 2 times is 6, right? Omega 4 6, plus when n equal to 3, so we are going to get x of 3 omega 4, 3 times 3 is what? 9. And this is our equation 4. So now these are the 4 equations that we have. Based on this, we can form a linear transformation equation, like the way, or a linear combination, right? Equation from this one, like the way we did for n equal to 2. So based on that, we can come out with the matrix, which is x of 1, x of 2, or let's say x of 0, x of 1 here, and then x of 2, and then x of what? 3. So this is what I have for now, and then based on that, I will say is equal to, so I'm forming the linear combination. I'm doing it in such a way that I'll be able to multiply them back and get the original equation in case they need be. So looking at the first equation, they are all 0 0 0 0 0 0 0, which is here. They are all having the power of 0. They are all having the power of 0. They are having the power of 0. Sorry, 0 0. So since they are all having the power of 0, right, we need to write them 0 here. W4 power 0, W4 power 0, W4 power 0, W4 power 0. And then my second equation, which is k equal to 1, is also having 0, 1, 2, 3 as the power. So I can also write omega 4 power 0, omega 4 power 1, omega 4 power 2, omega 4 power 3. And then my third equation is having 0, 2, 4, 6 as the exponents. So we are going to get W4 power 0, W4 power 2, W4 power 4, W4 power 6. And then my last equation is also having an exponent to be 0, 3, 6, 9. So I can see W4 power 0, W4 power 3, W4 power 6, W4 power 9. And when we are done, this is our x of 0, x of 1, x of 2, x of 3, which is our input equation, which is given to us. And based on this, I can draw the Cartesian or the complex number plane once again, and I'll get the vertical line, and then I'll get the horizontal line as well. So with this, as I told you on, you can label it the way you want. So labeling it the way you want, from maybe 0, 1, 2, 3, 4, right, 5, 6, 7. Like you label it, so you can do it. Let me do it here so you see. So this is 0 because that is 0. W4 power 1, W4 power 2, W4 power 3, W4, see 0 here, W4 power 4, W4 power 5, W4 power 6, W4 power 7, W4 power 8, and so on. You can do that, and so on. So if here it's 1, here is -1, here is j, and here is also minus j. When you see W4 power 0, this means that the simplification of the complex number has already been done in the Twiddle factor. So here you don't need calculator. So you can just pick W4 power 0 to be 1, W4 power 0 to be 1, W4 power to be 1, W4 power 1 to be what? Minus j, and then W4 power 2 to be what? Minus 1, right? And W4 power 3 is also supposed to be what? J. and so on. So W4 power 4 here, it's going to give us 4, it's going to give us what? 1. W4 power 5 is giving us minus j. W4 power 6 is giving us minus 1. And W4 power 7, right? Yeah, W4 power 7 is also giving us j. So with this, you can use this ones to form the matrix. So you can use that one to form the matrix. So if you are using that one to form the matrix, we can form it as x of 0, x of 1, x of 2, x of 3. This is our output. And then based on this Twiddle factor, the method we have done here, and I've also used this Cartesian plane. We label it as W4 power 0, W4 power 1, so from the clockwise direction. So based on that, and then the labelings here is 1, negative 1, j top here, and negative j here. Based on that, we are going to get some things like this. And based on this, anywhere that you see W4 power 0 is what? 1. So looking at this one, you can see that from here are all W4 power 0. And from here also all W4 power 0. So you can just write them 1, 1, 1, 1. And the down is also 1, 1, 1. Is what you have. And then the rest, you can see W4 power 1, power 2, power 3. Right? W4 power 1, power 2, power 3. So you are going to get something like minus j, minus 1, and then also j. And then the next one, we are going to get minus 1. And then we are going to get 1 here. And then we are going to get minus 1. And here we are going to get j, and then minus 1, and then minus j, right, based on this one, and then using this complex number plane. And then our input is going to be x power 0, and then x power 1, x power 2, x power 3. So this is how you'll be able to derive the linear combination out of the equations that we got. And we are going to use these ones to solve some DFT questions. And remember that this part, they are constants. You're supposed to know them, right? You don't have to waste much time on it. For the 2-point DFT, this part is also always constant. You are supposed to know. So in my next tutorial, we are going to solve some example of 2- and 4-point DFT using the Twiddle factor method or the linear transformation method. Thank you for watching, and see you in my next tutorial.